Chapter 11, Basic Properties of Circles, Part 1. Please turn to page 4. In this video, I would like to introduce some basic concept of circle, and I will introduce some theory or property of inside the circle. First of all, let's see some definitions. I believe most of you know what is the mirror center, radius, diameter, and then circumference. So I just want to introduce how can we call this length. If we have 2 points A and B are on the circle, if we draw a straight line, this straight line we'll call a chord of a circle. The longest chord of a circle is diameter. If I want to describe this length, if AB are 2 points on the circle, if I want to describe this length, we'll call this is an arc of a circle. Because we have 2 arcs related to AB, one is this part, another is this part. We'll call this part is minor arc, arc AB, minor arc AB. And the longest one, we'll call this is major arc. So, second part. I mentioned before, now if we have a chord AB, we can separate this circle into 2 parts. The smallest part, we'll call this a segment. So we'll use minor segment to represent it. And the largest part we'll call major segment. And in S3 and S2, we know the name of this part. We'll call this a zeta OAB. Similar to the previous idea, because if we consider the whole circle, we have 2 parts. So in this part, we'll call this as minor zeta. And the largest part we'll call major zeta. So the last one, I want to define 2 angles. Consider this circle. This circle, we have arc AB. Can you see this angle is subtended by this arc length, arc AB. So we'll call this as angle at center, subtended by arc AB. And then this angle is also subtended by AB. So we'll call this as angle at circumference. Subtended by arc AB. Okay, let's see the first properties. The first 2 properties are similar. Okay, let's see. What is the theorem 1 and theorem 2? If ON is perpendicular to AB, that means if this is 90 degrees, you can conclude AN is equal to NB. If you want to prove it, not very difficult. Why? Because you can consider these 2 triangles, ONA and ONB. These 2 triangles are congruent. Why? Because OA is equal to OB because this is radian. Okay, radii, and then I know ON is equal to ON, common side. If ON is perpendicular to AB, that means this is 90 degrees, this is also equal to 90 degrees. So RHS, these two triangles are congruent, so AN is equal to NB. The abbreviation is corresponding angles congruent triangle. But next time, if you want to prove it, you do not need to prove it. Congruent triangle, you can write down line from center perpendicular to chord bisect chord. That means line from the center perpendicular to this chord bisect this chord. Conversely, if AN is equal to NB, you can also prove ONA is 90 degrees. Same idea, congruent triangle, so corresponding angles. But the abbreviation is line from center to midpoint of chord perpendicular to chord. Let's see cast practice. So cast practice 1, because this is 90 degrees, I know AM is equal to MB. So AM is equal to MB. Because the abbreviation is line from center perpendicular chord bisect chord. So I know AM is also equal to 4. So X is equal to 8. Same idea, question 2, perpendicular. 3x plus 5 is equal to 6. So 3x is equal to 6 minus 5 is equal to 1. So X is equal to 1 over 3. Let's see next page, page 6. You can also use the same idea to find the answer. How about theorem 3? If I know CM is perpendicular to AB and AM is perpendicular, AM is equal to MB, then we can also prove CM pass through the center O, and the abbreviation is perpendicular bisect of chord pass through center. Okay, let's see 2 more examples. Example 11.1. Given this is 90 degrees, OC is equal to 7, OB is equal to 25, ask you to find the length of AB. I know 25 square is equal to 7 square plus CB square. So CB is equal to 24. This is according to Pythagoras' theorem. As CO is perpendicular to AB, so CB is equal to AC, because line from center perpendicular chord bisect chord. So AC is also equal to 24. So AB is equal to 48 cm. Example 11.2. I want to find the unknown K. It is given that BE is equal to ED. Given. Then I can conclude angle BEO is equal to 90 degrees, because line join center to midpoint of chord perpendicular chord. So angle EBO is equal to 180 degree minus 90 degree minus 40 is equal to 50. Angle sum of triangle. Okay, let's see one more example. I want to do the 4x2 with you. In the figure, O is the center of a circle. I know AN is equal to NB is equal to 3 cm, and then OQ is equal to 1. I ask you to find the radius of circle. First of all, I know ANO is 90 degree. AB is equal, AN is equal to NB, given. So I know angle ANO is equal to 90 degree. Line from center, line join center to midpoint of chord, perpendicular chord. Now I know this is one angle triangle. I can let R be the radius. OA is equal to R, and then one hidden information you need to know is NO is equal to R minus 1. So R squared is equal to R minus 1 all squared plus 3 by using Pythagoras theorem. So you can solve it. R is equal to 5. Another two theorems related to the chord and the distance. First, which is related to the length of the chord and the distance from the center. If I know we have two chords, one is AB and another is CD. If AB is equal to CD, then I can imply the distance from the center are also equal. That means OM is equal to ON. And not very difficult to prove it because by observations you can rotate this segment and then you can overlap this segment. So ON is equal to ON, or you can construct the triangle to prove these two triangles are congruent, and then the corresponding height is also congruent. Conversely, this is true because if I know OM is equal to ON, then I can also prove that the chord of CD is also equal to the length of the chord of AB. So the abbreviation like this: equal chord, equal distance from center. If AB is equal to CD and OM is equal to ON, then okay, you can use these abbreviations. If you want to use ON is equal to ON to prove AB is equal to CD, you can use these abbreviations. Chord equal distance from center are equal. That means chord are equal, Y equal distance from center. So class practice. Given that AB is equal to 12 cm, and then CD is also equal to 12 because 6 plus 6. So I know the distance from the center are equal, so Y is equal to 8 cm. Similarly, because the distance from center to this chord is also equal to 9 cm, and also this is also equal to 9 cm. So I know CD is equal to AB, and then you can find the values of Y. Y plus 2 is equal to 20. So Y is equal to 18 cm.